Good evening, everyone. I'm Professor Andrei Zvelindovsky from School of Mathematics and Physics at the University of Lincoln here in the United Kingdom. A very warm welcome to everyone who came. And I'm also very pleased to have our speaker with me tonight, Professor Don Kurtz. Hello, Don.
Hello, Andrei.
This type of activity we have today is our first attempt to have a chart about something happening in Astro world right now. So we organize it as a 30-minute session. However, Dawn is very kind to stay a little bit longer if will be more questions. Event will be organized the following way. First, Dawn will say a few words about Supermoon. This is subject of our chat today, and then will be floor open for all questions. So I ask everyone who came, and we have now already 50 people with us watching, to put whatever questions you might have in a chat or for a YouTube video. Then we will try to answer as many of those questions as possible. And again, very warm welcome to everyone who came, and I see people already greeting each other in the chat. We're very pleased to see, and more people are joining. I see already 58 of visitors here. I want to tell much about introducing Dawn. Dawn is a regular speaker in our lectures which we organize in University of Lincoln, and we are very privileged because now Dawn is also visiting professor in our School of Mathematics and Physics. Dawn has a long and distinguished career in astrophysics all around the world. And if you would like to read more about his biography, please just go down in the description of this video on YouTube, and there is a link to Dawn and his biography. Just to mention, in his long career, Dawn served as professor in several places and also was vice president of Royal Astronomical Society. He is prolific public speaker all around the world, sometimes in very exotic locations. Tonight, Dawn chosen a topic which many people often ask various questions. It is Supermoon. I'll give floor to Dawn. Thank you, Dawn, for being tonight with us. Just also to tell, Dawn is now currently in South Africa. So thanks to computer and the connections, we can be together while separated by space.
Thank you for the introduction, Andrei. And well, good evening to everyone who's in Lincoln or in the UK, and good whatever time of day to the rest of you who might have joined from somewhere else. I do want to talk to you about Supermoon tonight, and so just give me a moment here, and I'm going to pull up just a few slides to get us started. In Romeo and Juliet, Romeo swears his love for Juliet by yonder blessed moon, and Juliet cuts him off. She interrupts him, and she says, "Oh, swear not by the moon, the inconstant moon, that monthly changes in her circled orb, lest that thy love prove likewise variable." Well, Juliet was right. The moon is inconstant. We all know that. It goes through its phases from new to first quarter to full to third quarter back to new again over a month. But she wasn't right about the circled orb. The moon does not orbit the Earth in a circular orbit. The reason Juliet didn't know that is that Shakespeare didn't know that. He was writing in the late 1500s, and at that time, it was thought that all motions in the sky were on perfect circles. It was just a generation later that Johannes Kepler, the great German astronomer in the early 1600s, showed that the planets move about the sun on elliptical orbits. And then in the 1630s, the teenage genius in Lancashire, Jeremiah Horrocks, proved that the moon also moved in an elliptical orbit about the Earth and followed Kepler's laws. Now, the ellipse is a geometric form that was actually first written about by a Greek astronomer, Apollonius of Perga, 300 years BC. And unfortunately, the idea that things could move on elliptic orbits was killed by the greatest authority of antiquity, Aristotle. And following that, it was 2,000 years after Apollonius before Kepler finally brought the ellipse back into our thought. And so here's a greatly exaggerated view of the moon's orbit about the Earth. Let me just generate myself a little pointer here so that you'll be able to see what I'm pointing at. And I think the blue one will be best. Just bear with me a moment, folks, while I get my color here. There, I think you'll be seeing a blue pointer here. As the moon orbits the Earth, it has a closest point. Peri is Greek, meaning closest. G is the same as in geology, geography. That means closest to the Earth. Apo is furthest, that's farthest from the Earth. And you'll see that the moon comes in quite a bit closer at its closest approach to the Earth, and then goes quite a bit further away, although this diagram is greatly exaggerated in terms of the scale. And when the moon's closest to the Earth, it looks bigger in the sky. When it's farther away, it looks a bit smaller. It was only 1979 when an astrologer decided that he would start calling the full moon, when it was at perigee, the closest point, a supermoon. And that idea stuck on. People have enjoyed that idea that you can have a supermoon. And when the full moon rises, last month in April, this coming May, we'll have another supermoon. When the moon's close to perigee, as it rises at full moon, it looks spectacularly big on the horizon. And that's generally what all the excitement's about. But in fact, it's not actually much bigger than any old regular full moon. Here are two pictures of full moons, one on the left taken when the moon's near perigee, call that a supermoon now, and one on the right taken when the moon's near apogee in a different month, a different time of year, and that's sometimes called a mini moon or a micromoon. And the difference in size in the sky is only about 30% in area. That's probably something that you wouldn't notice. The moon just looks huge on the horizon, and something that's called, it's an optical illusion. It's the moon illusion. And so what happens is that the news announces there's going to be a supermoon, and people go out and watch the moon rise. And, you know, an awful lot of people just don't watch the moon rise very often, and they're really surprised how big it is. Well, every full moon rising looks big. And so let me give you some perspective on that. Here is a concocted diagram on the left here with a picture of the full moon up at the top near the horizon looking really huge, and a picture of the full moon exactly the same size, but against some railway tracks. And I think you'll agree that the moon at the top looks a lot bigger than the moon at the bottom, even though I tell you they're the same size. Over on the right of this picture is a multiple exposure of a full moon rise. You'll see that the sky's glowing pink here. The full moon has to rise at sunset. When the moon is full, it's opposite the sun in the sky, and so full moon always rises at sunset. When you go to look at that supermoon on May the 26th in a few weeks' time, you're going to be wanting to watch opposite the sunset, watch the moon rising. And in this picture, multiple exposures have been made as the moon rises, and you'll see the moon's not changing in size at all. Now, over on the left, you may not be believing me that those two moons are the same size, so I drew a box around them. And I think that may help you. And then I thought the railway tracks are still a bit disturbing, so let's block them out too. And I think you'll now see that both those images are the same size. Here's another optical illusion that illustrates how we get the moon illusion. If you see the moon up in the sky is huge. It's really big. And when you see the moon up in the sky, it's in these vast spaces, and those are represented here by these big circles. And so the moon looks small compared to the big circles. When it's down near the horizon, the things around it look smaller, and the moon will look bigger. And I think you'll agree with me, most of you will. This moon here looks smaller than that one. But again, they are the same size. And to try to help you see that, I just threw a grid on top of this. And if you look at the number of squares, you'll see this moon and that moon are the same size. So it's the moon illusion. There's nothing really special about the supermoon, except it looks a little bit bigger in the sky, and it gets people out to watch the full moon rise, which is always spectacularly beautiful. And there's a telephoto picture of a full moon rise with Lick Observatory in California in the background. This is not Photoshop. This is just done with a telephoto from a distant hill. And with the telephoto making the moon look very big, the moon being much further away than Lick Observatory, you get this beautiful juxtaposition and the moon looking giant on the horizon. So this next supermoon, if you'd like to watch it, will be on the 26th of May, and the moon will rise at sunset, as all full moons must. Now, why don't we get a supermoon every month? And the reason is that month, which comes from the word moon, month is just month, the moon orbits the Earth in 27.32 days. And so every 27.32 days, the moon goes through perigee, that closest point. But that's not what we know as the month. What we know as the month is the time for the moon to go through its phases, the time from new moon to new moon, or from full moon to full moon. And that's 29.53 days. You'll see it's 2.2 days longer. And so when we get a supermoon this month, when we get to June, by the time we get to full moon again, we will have gone a couple days past perigee. And then in July, we'll have gone 4 days past perigee. And so the full moon will be getting smaller and smaller and smaller until those 2 days add up, and the supermoons will come back next year in 13 or 14 months. Now, every month, the moon goes through perigee. And so really every month there is a supermoon. It's just not usually at full moon. It's really interesting when the moon is at perigee and it's new moon, because twice per year, the new moon passes in front of the sun. And here's a picture of a spectacular solar eclipse with the moon at perigee, closest point of the Earth, so that it looks big in the sky and it's completely covering the photosphere of the sun, so you can see this spectacularly beautiful corona with the sun's magnetic field guiding the hot gases. If we get a total eclipse of the sun when the moon's at apogee, at its farthest point, it actually can't cover the sun, and then we get something called an annular eclipse. And there's a very nice picture taken with a telephoto from a distant sand dune in the United Arab Emirates of an annular eclipse of the sun a couple of years ago. The last thing I want to tell you about before we go to questions is it's not just the moon that has phases. This is a real picture taken by the Apollo 17 astronauts as they were returning to the Earth after having landed on the moon. They see the Earth as a crescent in the sky. People are going to go back to the moon. The Chinese are planning missions to the moon to put people on the moon. The US is planning that again. Other countries are planning to put people back on the moon. And if you can be an astronaut, some of you out there young enough, maybe it'll be you. If you can be an astronaut and go stand on the moon and look at the Earth in the sky, when we're looking on a full moon, the moon's opposite the sun in the sky. From the moon, the Earth is towards the sun. It'll be new Earth. And then as the moon goes through its phases from full to new, the Earth goes through its phases from new to full. And so the Earth has a full set of phases too. For astronauts on the moon, that'll be spectacularly beautiful. And I think you'll agree, looking at this crescent Earth, it's even more beautiful than the moon is here from the Earth. So with that, we're going to stop, and that should at least set off some questions for you. And it's now just, it's a free-for-all. It's questions and answers. And please send your questions to Andrei, and he'll tell me what your questions are. And that should be possible to bring me up here too, Andrei. Am I down in the corner for you?
Yes, you are back here. Thank you very much, Don, for fantastic presentation. I see comments in a chat from Nicola, beautiful pictures. So now it is time for questions. So everyone who is watching, and I see 77 people watching this video, if you could please put any questions you might have on this topic in the chat, and Don will answer that. And I see I think there is question now from somebody with Ellen thinking ahead. Does the orbit generally move away from the Earth?
I'm not quite sure I understand that question. The moon's orbit around the Earth is permanent. Maybe I do understand your question. Is the moon drifting farther away from the Earth?
Probably yes.
Let me think that that's what you're asking, and the answer is absolutely yes. The moon's orbit is getting bigger. So the moon will continue to orbit the Earth, but at a greater and greater distance. And we bounce laser beams off of mirrors that were left on the moon by the astronauts when they were there back from 1969 to 1973. And we can measure the distance to the moon to a precision of 2 centimeters. The moon is drifting away from the Earth at 4 centimeters per year. It's getting farther and farther away. And so if you like solar eclipses, I told you that when the moon's at perigee, it can cover the sun completely and you get this beautiful solar eclipse. But that's only true for the next 600 million years, and then the moon will be too far away to cover the sun. So don't wait too long to go see your eclipses. They're not forever.
Right. There is another question from Nicola, who complimented also for pictures. Do other planets get supermoons?
Do other planets have moons which orbit in eccentric orbits? And the answer is certainly yes, they do. But let's think of the problem. The planets that you might stand on, if we can provide you with the rocketry and take you to another planet, you could stand on Mercury. Very, very hot on the side near the sun, very cold on the other side, but Mercury has no moon. You might go to Venus, but if we put you on the surface of Venus, it's 460 degrees Celsius, you'll be boiled. The pressure's 90 atmospheres, you'll be crushed. The atmosphere is carbon dioxide, you're going to suffocate, and the clouds are made out of sulfuric acid, you will be dissolved. And it has no moon. Mars has 2 moons. They're tiny, little Phobos and Deimos. And I don't think you're going to get a feeling of a supermoon for those because they go screaming across the sky. Carl Sagan famously called them the hurtling moons of Barsoom. Barsoom being a fictional name for Mars in some science fiction stories. And they're so close to the ground, moving so fast, you're not going to notice that. So then when you go to the outer solar system, Jupiter, it's got uncounted moons if you go down to small sizes, Saturn too, but you can't stand on Jupiter or Saturn. They're all gas. There's no surface to stand on. So really, supermoon, it's here on the Earth. That's it for the solar system. This is where you're going to see it.
In fact, there was a question about Jupiter from Luc Bideau. How do Jupiter moons behave with regard of eclipse and the like?
Well, if you are on Jupiter, you can watch Jupiter's moons. It has equatorial moons, the 4 big moons of Jupiter, Io, Europa, Ganymede, and Callisto. By the way, Io and Europa are the size of the Earth's moon. Ganymede is bigger than Mercury, and Callisto is about the size of Mercury. They pass in front of the sun, but from the point of view from Jupiter, let me think. Actually, they're very close. That's a good question. Would they eclipse the sun or would they only transit it? I'm going to have to answer that in the next chat session. I haven't thought about it. That's a very good question. If we could float in an airship in the atmosphere of Jupiter, would little Io, because the sun's much smaller from there, I'm going to say that probably you get a total, oh, in fact, I know you do, you get a total eclipse. I just figured it out. From here on the Earth, we can watch through small telescopes, and we can see the shadow of Io and Europa passing across Jupiter, and it makes a nice black shadow. And if you were standing in that shadow, you would then see the sun totally eclipsed. So I found the answer out. Yes, from up in the atmosphere of Jupiter, floating around in your Montgolfier hot air balloon, if the shadow of Io or Europa, Ganymede, or Callisto passes across your balloon, it will block the sun out completely and you'll get a total eclipse. Yes.
Thank you, Don. I need to read. There are lots of questions arriving. Question from Prethan Mittal. What is pink moon or harvest moon?
Well, I think the pink moon was last month, and you can look up on the internet if you like. The harvest moon, let's do the harvest moon. The harvest moon is reasonably universal in the Northern Hemisphere. It's a moon that comes in September around harvest time for the crops. And if you're harvesting the crops, especially by old-fashioned means where you don't have tractors and machinery, and you're actually out doing it by hand, you've got to get it done quickly. If you wait too long, if the rains come, the crops get ruined. And so people will work at night too. And if you've got a full moon at that time, it gives you light to work by back before there was electricity. And so the harvest moon makes sense. I think the next one after that might be a hunter's moon. and it would be associated with hunting. The pink moon is very recently named. I think it was last month. It's an American name, and it's because there's a beautiful flower that blooms somewhere in the States that's pink in April, and so they decided to call it a pink moon to match the flower.
Thank you.
The moon is not pink at that time. It's got nothing to do with the color. The moon is black. The moon's the color of coal dust. It's basically basaltic lava.
This question from Hypatia. As the moon is drifting away from the Earth, will there come a distance at which the tidal locking ends?
Yes, it's a very good question. The moon is drifting away from the Earth, and that means that the length of the Earth's day is getting longer. And, well, the tidal locking will be fixed both ways. Let me not say it ends. The Earth will also become tidally locked to the moon. And then the length of the day here on the Earth and the length of the month for the moon to orbit the Earth will be equal to each other at about 47 current days. But there's a problem. And the problem is that the time scale for that may be so long that the sun will swell to be a red giant and destroy the Earth and the moon before it happens. We're not absolutely sure that the sun's going to totally destroy the Earth and the moon. It's certainly going to blow away the atmosphere. But if it doesn't quite get out to the Earth's orbit and some remnant of the Earth and the moon survive, they will both be tidally locked with one face of both of them towards the other in complete tidal locking. So no changes in the tidal locking. But no, the tidal locking doesn't come to an end. It becomes complete.
Right. I just kind of want to ask as well, you mentioned Apollonius, you mentioned now our famous Jeremy Horrocks from England. When Asian people kind of saw moon, and moon probably most observed object in the sky for us, right? We cannot see, I can see it without even my glasses. When they observed this difference in size, what were their conclusion? Is it what pushed them to think about elliptical orbits 300 years before BC, or it did not influence them much about?
All right, Andrei, I don't think that the Greeks were thinking about elliptical orbits. Apollonius of Perga was a mathematician, and he was interested in conic sections, which include ellipses, hyperbolas, parabolas, and circles. And so he was just doing the mathematics. He was not connecting that to the sky. The dogma up until the time of Kepler in the early 1600s was that everything in the sky had to move on perfect circles. And the great Greek-Egyptian astronomer Ptolemy solved that problem by having things move on circles on other circles. They were called epicycles. And so the moon would be seen to be further away and closer away, and that was because it was moving on a circle, but the circle wasn't quite centered on the Earth, and that center was moving on another circle around the Earth. So there was no physics in this. It was just circles within circles until you could actually explain the motion. And Ptolemy's tables were very good at predicting where the planets would be and how far away they would be, size in the sky, I mean. But with circles within circles within circles.
Right. Okay. Thank you. There is a question here. I cannot quite read the name, quite long, so I just read the question. Why is that the moon is just big enough and at the right distance to eclipse the sun, different size at different distances, would it not? Are we just living in a fortunate period of time?
The answer, yes, to your last question. We are living in a fortunate period of time. As I mentioned a moment ago, the moon will, 600 million years in the future, be too small ever to cover the sun. There'll be nothing but annular eclipses. The moon used to be a lot closer to the Earth. The length of the Earth's day was a lot shorter. If you go back 400 million years, there were animals living on the land, there were plants. The length of the day was 21 hours. The moon was closer, and total eclipses were longer. We just happen to be here at the right time where the moon size and the sun size in the sky just match. Good luck on our part.
Okay, there is some question maybe in discussion from Thinking Ahead. The eclipse were as a result of Tycho Brahe's observation with Kepler's interpretation. It's probably a comment related even a bit about your last lecture.
Oh, you were asking about the ellipse and the relationship between Tycho and Kepler.
Yes, yeah.
Yeah, well, Tycho didn't actually believe Copernicus. Tycho didn't believe that everything in the sky orbited the sun. He had to concede that Mercury and Venus did. That was rather inescapable, but otherwise he had the sun and all the other planets orbiting the Earth. And he wanted to be the most famous person of all time to show that that was the true model of the universe. It's the reason why he held back his observations from Kepler and gave Kepler the hardest planet that he had observed, which is Mars, because Mars has a very eccentric orbit. It's almost 10% eccentricity. And that made a very difficult problem for Kepler, but it does mean that once he got his mind around it and tried the ellipse, it was such an extreme case he could see that he was right.
I see also a question from John Clark. Is Earthrise from the moon a myth?
Sorry, John, no. Not as seen from an orbiting command module. So the Earthrise, the pictures of the Earth rising over the edge of the moon from a satellite orbiting the moon is very real. Each time the satellite goes around the moon, it goes into the shadow on the dark side of the moon, the far side, where the sun's not shining, and then it comes back out. And as it comes around, the Earth will come into view. You may be thinking, what if astronauts were standing on the moon? Astronauts standing on the moon will not see Earth rise and they will not see Earth set, because the moon is locked to the Earth. It rotates at the same rate it orbits, and the face that we see is always the face we see. So if you're standing on the moon, on the side that the Earth is on, you'll see the Earth up in the sky, and it will move a little bit because of the moon's elliptic orbit, but it doesn't move much and it doesn't rise and set. So for an astronaut on the moon, Earthrise is not true. For an astronaut or a camera on an orbiting satellite, you get an Earthrise every time the satellite comes around. And those pictures are real.
Thank you. Pratham Mittal is asking, why moon loses its magnetosphere?
I didn't know it had one. So is your question, why doesn't the moon have a magnetic field like the Earth does? And probably the answer to that is the moon has a surprisingly small core. You may know, let me say it anyhow, half the Earth's radius is taken up by its core, which is made largely out of molten iron and nickel in the outer part and solid iron and nickel in the inner part. And its flowing currents in the many thousand degree molten iron and nickel, which are good conductors, that generate a dynamo that manufacture the Earth's magnetic field. The moon's much smaller. It has a surprisingly small core, and somebody else can ask the question why that might be. That has to do with our lack of knowledge of the formation of the moon. But the moon's core will be solid, not liquid, and it won't have flowing currents in it, and those flowing currents are largely what are needed to generate a magnetic field. Now, just to jump ahead in case you were going to ask me, but what about the magnetic fields on moons like Ganymede and Callisto around Jupiter? It's true they do have weak magnetic fields, and we think that those are generated in oceans, which are saltwater, and they also can carry weak currents and generate magnetic fields. The moon doesn't have that, and so it doesn't generate a magnetic field.
I see a question from Matthew Arnold. How many moons does the Earth really have? I've heard there are some small ones. Is it true? If so, do they have any names?
The International Space Station. All of the human-made satellites that are orbiting the Earth are technically moons of the Earth. The definition of moon is a smaller body that orbits a planet. That's our made-up definition. And so is your question, do we have any natural moons like small asteroids or something like that orbiting the Earth? It's possible that over time, over the life of the Earth, the 4.65 billion years, occasionally some small asteroids may be captured into orbit about the Earth, but in the interaction with the real moon and the Earth, eventually ejects them again. And I don't personally know of any rock big enough to naturally orbiting the Earth that we can see. Now, there's almost certainly dust and microparticles and little tiny pebbles orbiting the Earth as little tiny moons that we can't detect, that are captured. They're probably there all the time.
Thank you. I just mentioned that although our time, official time finished, so if everyone wants to leave, so to say, yes, we don't kind of keep doors locked. However, Dawn is very kind to try to answer as many questions as possible. So if you would like to stay with us, please do so as well. There is a question from Nicola. How do we know that the moon was closer to us in the past?
Oh, that's a very good question, Nicola. And the answer is with two ways. One is we take the current rate that it's going away and just say if it's been going away at this rate over the last 4 billion years, where was it 4 billion years ago? Now, the rate of drift away from the Earth won't be exactly constant, but we can extrapolate backwards in time to see that the moon must have been closer. But the other important part of that is the spin of the Earth is slowing down, and it's the loss of that spin of the Earth that's giving the moon extra angular momentum, we call it, that's causing it to drift away. And we can make measurements of the length of the day in the past from plant records, from geological records, and see that the day was shorter. And so there is evidence that the day was shorter, and if the day was shorter, that could only be true if there was extra spin, and that has to come, the moon would have to be closer in that case. And so there is evidence for that. We do know it. Our calculations of exactly how long the day is and exactly how close it is become less precise as we go farther and farther back into time.
Thank you, Don. I see there is a question about basically the dynamics of multi-body system from Phil Riggs. Your presentation assumed the Earth was static, but of course the Earth is cycling the Sun. Is the Earth orbit also elliptical, and how does that affect the Moon's orbit around the Earth?
Okay, so Phil, you've asked a hard question, and since you've asked a hard question, let me say no matter what I tell you, it's more complicated than that. And so let me start and work up towards some of the complexities. Yes, the Earth orbits the Sun on an elliptical orbit. That's very important for total eclipses of the Sun, because if you get a total eclipse when the Moon's at its closest and the Sun's at its furthest, that's when you get your longest eclipse. It can be over 7 minutes. If you get an eclipse when the Sun's closest, so it looks bigger, and the Moon's furthest, so it looks smaller, that's when you get these annular eclipses. So the Earth is in an elliptical orbit around the Sun. The Moon is in an elliptical orbit around the Earth, except it's more complicated than that. Because the Sun is also tugging on the Moon's orbit as the Moon orbits the Earth, and the Moon's orbit is not a perfect ellipse. It's being perturbed by the Sun. It's even being perturbed by the other planets. And that's true for the Earth too. We call the Earth's orbit an ellipse, but we can measure the distance from the Earth to the Sun now to a precision of a matter of a few meters. And with that sort of precision, we can see the Earth get tugged away from the Sun when it passes by the little tiny asteroid series out in between the orbit of Mars and Jupiter. We can see the Earth being tugged about by Venus, by Mars, by Jupiter, by Saturn, and it wiggles all over the place at the precision we can measure it of a few meters. And so it's easier to tell you it's an ellipse, it's easier to picture that, but when you get to the highest precision measurements, we can see that none of the planets or moons are orbiting in perfect ellipses because there's so many bodies around and they're all tugging each other.
Thank you, Don. There is another question on basically mechanics of movement of bodies from Team Play. And it basically, will eventually Moon fly away or fall to the Earth?
Okay, the answer to that, Tim, is no. The Moon's drifting away from the Earth. And when it gets to a distance where the Earth is slowed down so it's got one face locked to the Moon, then they will remain locked in that orbit. As long as the Sun doesn't destroy them when it becomes a red giant, they will remain like that for eternity.
Thank you, Don. A question from Anthony. Does the moon tidal affect only water, or does it affect other things?
The moon's tide affects everything. The reason why you notice it in the water is the water can flow, it's fluid. And so with the water flow, you can get some very high tides. But the moon also stretches the Earth. The tide is a stretching force. And when the moon passes at its closest to the zenith, if you're down in the tropical regions, it can go through the zenith. The Earth will stretch away from the surface of the Earth, will stretch away from the core of the Earth by up to about 10 centimeters. On the other hand, the Earth's tides on the moon are much bigger, and the moon's surface stretches by more than that because the Earth stretches it. So there are tides on the moon too. So yes, you get Earth tides. You even get tides between your head and your feet when you're standing underneath the moon, but they are microscopic at the level of even the nucleus of an atom, and there's no way anybody could ever measure that. But technically it happens. And where you would notice it is if you got close to a black hole, because then the tides between your head and your feet would pull you to pieces and you would get shredded.
Thank you, Don. And as you mentioned about tides, sometimes you can find on internet or YouTube or even some news outlets that people tell the supermoon creates larger tides and there is earthquakes and this and that. So can you comment? Should we be really scared next time the supermoon about earthquake?
Okay, I can answer that very well. I actually did answer it earlier, but not in that context. There is a supermoon every month. The moon goes through perigee, its closest point to the Earth, every single month. It just doesn't happen to be at full moon, but the earthquakes don't care about the moonlight shining on the ground. And so what you will find is the people who are claiming that earthquakes are correlated with the full moon, they'll tell you that most earthquakes occur between 10 days before a full moon and 10 days after a full moon. And I agree with that completely, because 10 days before and 10 days after is 20 days, and that's 2/3 of a month. And that means that 2/3 of the earthquakes are going to happen in that period. But no, the moon, the tides from the moon may cause stress on faults on the Earth. It's possible there could be some earthquakes set off by that. And so maybe, but this happens every month. And we don't see any strong correlation with that. So it's got to be a very tiny effect. And it's got nothing to do with the moon being full, where it is with respect to the sun.
Right. Okay. This is rather reassuring. So I will sleep a bit better the next time supermoon comes. Looking that we already like a little bit more out of time, and although we did not maybe manage to answer completely all the questions, but I think we've done quite well in our first inaugural event for Astro-Chat. And I do hope that we can convince Don to talk us soon about some other topic which happens in the sky, and we can have chat again and answer questions. So I would like to thank Don very much again. I also thank all the audience and everyone who put questions. Thank you very much, and I hope we can see Don again and chat again about something in the sky. Thank you, Don.
Thank you, Andrei. Thank you, everybody else. I hope so too. It's fun.
Bye.